Hello all, welcome back to Periodic Chemistry. In this video, we will learn about electrochemical series and the numericals. Although we have learned about some part of electrochemical series in my previous video, in this video it will be more clear and better understood. After watching this video, you will be able to determine the oxidizing agents, the reducing agent, and their order. So, let's start. Let's first study what actually the electrochemical series is. Arrangement of electrodes with their half reaction according to their standard reduction potential is electrochemical series. You can see a series on the right hand side of this slide. There are various reduction reactions given along with their standard potentials. These potentials are clearly the reduction potentials. Also, we can see that the arrangement is from the highest positive to the lowest negative. So, arrangement of this type of reactions is called an electrochemical series. Although this series is a small part of the electrochemical series, you can find the whole electrochemical series in your textbook, or you can also use any search engine to learn more about it. Reduction potential is measure of tendency to attract electron and get reduced. This means reduction potential tells about the tendency of a reaction to undergo reduction reaction. So after summarizing these two definitions and this electrochemical series, we can make an approach to solve our numericals. When there will be a higher reduction potential, that time that reaction has a tendency to undergo reduction reaction. And the reagent which itself undergo reduction reaction is an oxidizing agent. So we can tell that whenever there is going to be a higher reduction potential, that time that reagent is going to be an oxidizing agent. Also, you can see that all the terms on the left-hand side of the reduction reaction are oxidizing agents, while the term on the right-hand side of the reduction reactions are reducing agent. The strength of oxidizing agent increases as we move from bottom to top, while the strength of reducing agent increases as we go from top to bottom. So we just need to remember these 2-3 concepts and we can solve any type of numerical that is based on electrochemical series. Let's solve a numerical and make it more clear. Let's solve 7th example under question number 4, Maharashtra State Board 12th Standard Science textbook. Here we need to identify oxidizing agents and arrange them in the increasing strength. Various elements with their standard reduction potential is given. Let's see an approach to solve this problem. We can see a big circle to the left hand side, and when there is a loss of electron, we get a small circle to the right hand side. What does this mean? This means that big circle is a reducing agent and small circle is an oxidizing agent. Because we know when an element loses electron, it acquires a positive charge, and the element with positive charge are in smaller size as compared to the negative charge. Hence, we can summarize it like that oxidizing agents have a positive charge and reducing agents have a negative charge. Sometimes the oxidizing agent and reducing agent will have no charge. That time, we need to determine whether it will undergo oxidation reaction or reduction reaction, and that will decide whether that reagent is an oxidizing agent or reducing agent. Let's solve this example and see what it is actually. So it's clear that when the positive charge increases, the strength of oxidizing agent is going to increase. Another approach is when there is a higher positive reduction potential, that time it has a tendency to undergo reduction reaction. The reagent will itself undergo reduction reaction are the strong oxidizing agents. So first what we will do is we will write these given reduction potentials from a lowest magnitude to a higher magnitude. Therefore, minus 1.66 is going to be the lowest and 1.36 is going to be the highest. Now it's clear that Al plus 3 and Cd plus 2 having positive charge and being metals, they are oxidizing agent. Br minus is having a negative charge, and as we have seen that reducing agents have negative charge, hence Br minus is a reducing agent. That's why I've highlighted it in yellow color. Now remains Al, Fe, I2 and Cl2. Among these, Al and Fe are the metals. And we know that metals have a tendency to lose electrons and gain positive charge. Therefore, Fe and Al cannot undergo reduction reaction. And hence, Al and Fe having no charge are reducing agents. That's why I've highlighted this two part also in yellow color. But even I2 and Cl2 doesn't have any charge. But we know I2 and Cl2 are the halogens and they are most electropositive. Sorry, electronegative. That means they have tendency to attract the electron. And hence, I2 can gain 2 electrons and form 2 I minus. Cl2 can gain 2 electrons and form 2 Cl minus. Hence, they can undergo reduction reaction and that's why they are reducing agents. So from this example, it is clear that how we can determine the reducing and oxidizing agent when the element has no charge or it is neutral. Hence, the correct answer for this will be Al plus 3 is a smallest strength in reducing oxidizing agent and Cl2 is having an highest oxidizing agent strength. And the other terms are got eliminated. Let's see another example and make this concept more clear. Let's solve similar example. Here we need to arrange the reducing agent in the increasing strength. Here also various elements with the reduction potentials is given. Approach for this will be when negative charge increases, strength of reducing reagent increases. Also, when there is a lower negative reduction potential, that time it has a tendency to undergo oxidation reaction and the reagent itself undergo oxidation reaction is a strong reducing agent. Here we need to arrange the reduction potentials from the highest to the lowest, but the greater sign will be towards the reagent which is a strong reducing agent. So 1.61 is having the highest value while minus 2.93 is the lowest value. From this I have highlighted Br2 and Ag plus because these are the oxidizing agents. Br2 is an oxidizing agent because we know that halogens are electronegative and they have a tendency to attract the electrons. Therefore, Br2 cannot undergo oxidation reaction and hence it is a oxidizing agent. While in case of Ag plus has only one oxidation state that is plus 1. Therefore, this Ag plus cannot undergo further oxidation and hence Ag plus is also a oxidizing agent. Nickel and magnesium are the metals and they have a tendency to lose the electrons and acquire positive charge. Therefore, they can undergo oxidation reaction and hence they are reduction agents. K is also having an plus 1 oxidation state, so it can also lose one electron and form K plus and hence it is also an reducing agent. In case of C and Ti, in spite they both are having a positive charge, they are reducing agent. Why? Because these are from the D block and D block elements can have variable oxidation state. Ce can have plus 4 oxidation state and titanium can also have plus 3 plus 4 oxidation state. That's why both the elements can undergo further oxidation and hence they are the reducing agents. Therefore, from this series, we need to eliminate just two terms, Br2 and Ag plus, and our final answer will be C plus 3 being a lowest reducing agent while K being an highest reducing agent. So this is how we can apply a knowledge of electrochemical series and find the strength of the reducing agents and the oxidizing agents. Whenever the reduction potentials are given but the series is not given, we need to determine the reaction that element can undergo and decide whether it is an oxidizing agent or the reducing agent. Alright, this was all about this part of electrochemistry. For the further concepts, you can watch my other videos and my previous ones. Please give your feedback so that I can improve myself and I can come up with new videos like this. Don't forget to hit the bell icon, like, share, comment, and subscribe. Till then, thank you and stay safe.